A dark fracture slices across the pale sandstone of southeastern Utah, cutting through one of the most famous canyon landscapes in North America. From a distance, it appears almost unreal, a narrow line etched into a vast expanse of rock. Step closer, and the illusion disappears. The opening widens beneath your feet into a deep void, plunging into darkness between walls of ancient stone. Known as the Black Crack, the formation has become one of the most photographed geological features in Canyonlands National Park. Yet its existence raises questions that continue to fascinate geologists and visitors alike. Why would an immense slab of seemingly solid sandstone split open in the middle of a desert plateau? Why does the fracture appear in a region already carved into thousands of canyons? And why do similar cracks continue to emerge across Utah's canyon country long after the rocks themselves were formed? The Black Crack is located along the White Rim area of Canyonlands, a landscape defined by cliffs, mesas, buttes, and deep river-carved canyons. The feature itself is not a fault in the traditional sense. It is a tension fracture, a type of crack created when rock is slowly pulled apart. Unlike earthquake faults, where blocks of rock slide past one another, tension fractures form because the stone experiences stress that exceeds its ability to remain intact. The result is a gaping fissure that can appear suddenly on a geological timescale, but is actually the product of processes unfolding over thousands and sometimes millions of years. Visitors encountering the Black Crack often focus on its depth. Estimates place the vertical drop at roughly 65 feet, equivalent to about 20 meters. The fracture is narrow enough in some places to step across, yet deep enough to disappear into shadow even under the intense sunlight of the Utah desert. Photographs frequently exaggerate the sense of scale because the opening appears so small at the surface compared with the darkness below. The contrast between width and depth creates the unsettling impression that the earth has been sliced open with a knife. Its length varies depending on how the fracture is measured, since the visible crack extends through multiple connected openings and smaller fissures. The principal section stretches for several dozen feet, while associated fractures continue through the surrounding sandstone. In some locations, the opening measures only a few feet across. Elsewhere, it widens enough to create a substantial gap. Depth, however, remains its most striking characteristic. The walls descend sharply into a narrow chasm where sunlight struggles to reach the bottom. The Black Crack occupies a landscape that appears stable from a human perspective, but is constantly changing. Canyonlands National Park sits within the Colorado Plateau, a massive geological province covering portions of Utah, Colorado, Arizona, and New Mexico. The plateau contains some of the most spectacular exposed rock formations in the world. Layer upon layer of sandstone, shale, limestone, and other sedimentary rocks reveal a history stretching back hundreds of millions of years. Many people assume that the dramatic scenery of Canyonlands was created entirely by rivers. Water certainly played a dominant role. The Colorado River and Green River cut deeply into the plateau, excavating canyons that reach thousands of feet below surrounding mesas. Yet erosion alone does not explain features such as the Black Crack. Beneath the visible landscape, enormous stresses continue to reshape the rock. One of the most important factors is the presence of ancient salt deposits buried beneath parts of southeastern Utah. During a distant period in Earth's history, shallow inland seas evaporated repeatedly, leaving behind thick layers of salt. Over millions of years, these deposits became buried beneath younger sediments. Salt behaves differently from most rock. Rather than remaining rigid, it can slowly flow under pressure. Geologists often compare the movement to extremely slow-moving putty. As the buried salt shifted, it altered the shape of the rocks above it. Some areas rose into arches and domes. Other regions sagged or stretched. This gradual deformation produced weaknesses that continue to influence the modern landscape. Even though the original salt movement began millions of years ago, its effects remain visible today in the form of fractures, folds, and canyon systems. The White Rim area where the Black Crack is located occupies a particularly dynamic setting. The sandstone surface appears solid, but it sits above steep canyon walls carved by erosion. As rivers cut deeper into the landscape, they remove support from adjacent rock masses. Imagine cutting away the base of a massive stone platform. The remaining rock begins to respond to changes in weight and pressure. Although movement occurs slowly, the stresses can be sufficient to create fractures. These fractures often develop near canyon edges. The rock closest to the canyon experiences less support than rock farther inland. Over time, gravity encourages slight outward movement toward the canyon. The process is measured in inches or centimeters over many years, but the accumulated effect can be substantial. When stress exceeds the strength of the sandstone, cracks begin to form. The black crack represents one visible expression of this phenomenon. Rather than being an isolated anomaly, it belongs to a broader family of tension fractures scattered throughout canyon country. Many remain hidden from public view. Others are visible as narrow openings running parallel to canyon rims. Some are only inches wide. Others expand into dramatic chasms large enough to swallow vehicles. Geologists once believed that the sandstone layers of the Colorado Plateau behaved as relatively stable blocks interrupted mainly by major faults. Increasingly detailed mapping and monitoring revealed a more complicated reality. Large sections of canyon rims are slowly moving. The movement is not rapid enough to resemble a landslide in the conventional sense, yet it is significant enough to generate extensive fracture systems. In some locations, instruments have recorded measurable displacement over time. The motion occurs because canyon walls continue adjusting to erosion. As rivers deepen their channels and remove material from below, the overlying rock gradually responds. The process is sometimes described as gravitational spreading. Massive rock slabs inch outward toward canyon voids, creating tension behind them. Eventually, fractures open. This understanding challenged earlier assumptions about how canyon landscapes evolve. Rather than viewing canyon walls as passive remnants left behind by erosion, researchers increasingly recognize them as active geological structures responding to changing stress conditions. The black crack became an especially striking example because it provides a visible window into these processes. The sandstone involved in the formation is itself remarkable. Much of the white rim consists of ancient dune deposits transformed into rock. Long before dinosaurs appeared, vast deserts occupied the region. Wind transported immense quantities of sand, building dunes that rivaled those found in modern deserts. Over time, burial and mineral cementation converted these sands into sandstone. The resulting rock possesses distinctive characteristics that influence fracture development. Sandstone is strong under compression, meaning it can support substantial weight pressing downward. It is less effective at resisting tension. When forces attempt to pull the rock apart, fractures can develop relatively easily. This difference explains why canyon country often displays dramatic crack systems despite the apparent durability of the surrounding stone. Climate also contributes to fracture growth. Utah experiences substantial temperature variations between day and night. Rock expands when heated and contracts when cooled. Although the daily changes are small, repeated cycles over thousands of years place additional stress on existing weaknesses. Water can further accelerate the process. Rain and snowmelt seep into fractures. When temperatures fall below freezing, ice expands within the cracks, exerting pressure on surrounding rock. The black crack likely originated as a much smaller fissure. Tiny fractures developed as stresses accumulated within the sandstone. Over long periods, those openings widened. Water entered. Temperature fluctuations enlarged the gaps. Gravity continued encouraging movement along the canyon margin. Eventually, the fracture became large enough to attract attention from anyone traveling across the white rim. Its appearance often surprises visitors because the surrounding surface seems relatively smooth. Desert landscapes are frequently imagined as rugged terrain where hazards are obvious. The black crack defies that expectation. The fissure can emerge abruptly from otherwise navigable rock. The contrast between open terrain and hidden depth creates much of its visual impact. The name itself reflects the appearance. Sunlight rarely reaches the deepest sections, causing the interior to appear black when viewed from above. Against the reddish and tan sandstone typical of canyonlands, the darkness creates a stark visual boundary. Photographs taken during midday often emphasize this effect, making the crack resemble an ink line drawn across the landscape. The feature gained wider attention as images circulated online. Viewers unfamiliar with canyon country geology frequently assume the crack resulted from an earthquake or catastrophic collapse. In reality, its development represents a much slower process. The fracture embodies geological change, occurring at rates almost imperceptible during a human lifetime. Yet slow does not mean insignificant. The dimensions of the black crack demonstrate the cumulative power of gradual forces. A fissure approximately 65 feet deep, or about 20 meters, requires immense amounts of rock displacement. The opening visible today reflects countless cycles of stress accumulation, fracture propagation, weathering, and erosion. The broader Canyonlands region contains numerous examples of similar processes operating on different scales. Along canyon rims, long fracture networks extend for hundreds and sometimes thousands of feet. Some remain narrow, others evolve into major topographic features. The distinction between a crack and a canyon is often one of scale and time. Given sufficient enlargement through weathering and erosion, a fracture can become a significant landscape element. This relationship highlights one of the most important lessons from the black crack. Landscapes are not static monuments. They are snapshots within ongoing geological change. The towering cliffs of Canyonlands may appear permanent, yet they are continually adjusting to erosion, gravity, and internal stress. Satellite imagery and modern surveying techniques have reinforced this perspective. High-resolution measurements reveal subtle movements across canyon rims that would have been impossible to detect in previous generations. In some areas, rock masses once considered stable are now known to be shifting incrementally. These observations help explain why tension fractures continue forming despite the great age of the surrounding rocks. The implications extend beyond scenic geology. Understanding fracture development contributes to assessments of rockfall hazards, infrastructure stability, and landscape evolution. Roads, trails, and recreational areas located near canyon rims may be affected by gradual rock movement. Monitoring these changes provides valuable information about future conditions. The black crack also serves as a reminder that erosion does more than remove material. By carving canyons into the plateau, rivers alter stress distributions throughout the surrounding landscape. Every foot of canyon deepening changes the forces acting on adjacent rock. Over millions of years, these adjustments create opportunities for fracture formation. Few places illustrate this interaction more dramatically than Canyonlands. The park occupies a region where river incision, tectonic uplift, and rock deformation intersect. The Colorado Plateau rose thousands of feet, while maintaining much of its structural integrity. Rivers responded by cutting downward, producing some of the deepest canyons in North America. As those canyons expanded, they generated new stress conditions within the plateau. The black crack emerged from this chain of events. Its existence depends on ancient deserts that supplied sand, buried salt layers that altered regional structure, uplift that elevated the plateau, rivers that excavated canyons, and ongoing gravitational forces that continue pulling rock apart. Remove any one of those elements and the fissure might never have formed. The feature therefore represents more than a dramatic opening in the rock. It condenses vast spans of geological history into a single visible landmark. Standing beside it means looking at evidence of processes operating across hundreds of millions of years. Despite its popularity, the black crack remains only one component of a much larger geological system. Similar fractures occur throughout southeastern Utah, especially near canyon edges. Some are hidden within remote backcountry terrain. Others appear beside roads and trails. Collectively, they reveal a landscape under continual adjustment. Researchers studying canyon country fractures often focus on patterns. Cracks tend to align with canyon rims and zones of structural weakness. Their orientation reflects underlying stress fields. By mapping fracture networks, geologists can reconstruct aspects of regional deformation and identify areas experiencing active movement. Such studies have altered perceptions of the Colorado Plateau. Rather than viewing the plateau as a rigid block merely dissected by rivers, scientists increasingly recognize a landscape responding dynamically to erosion and gravity. The black crack became famous largely because it provides a visually compelling example of those otherwise subtle processes. Its dimensions reinforce that point. A depth of approximately 65 feet or 20 meters demonstrates that tension fractures are capable of producing substantial openings. The visible length extends across a significant portion of the sandstone surface, while widths vary from narrow gaps to broader openings large enough to command caution. These measurements underscore the scale of geological forces involved. Viewed from above, the crack appears almost impossibly clean. The walls descend steeply with little loose debris visible near the surface. This geometry reflects the nature of sandstone fracturing. Rather than crumbling immediately, the rock often breaks along relatively sharp planes. Over time, weathering modifies those surfaces, but the overall impression of a precise split remains. The starkness of the feature contributes to its reputation. Many geological landmarks owe their appeal to size. The black crack achieves a similar effect through contrast. A narrow opening intersects an otherwise expansive landscape, creating a visual puzzle that demands explanation. Human perception expects gradual transitions. The fissure offers an abrupt boundary instead. That sense of contradiction explains why photographs continue circulating widely. Images compress depth into two dimensions, making the crack appear even more improbable. Viewers see a dark line crossing sandstone and instinctively question how such a feature could exist. The answer lies not in a single event, but in the cumulative effects of geological change. Across Utah's canyon country, those changes continue today. Rivers still erode, rock masses still adjust, fractures still widen. The black crack stands as visible evidence of a landscape far more active than appearances suggest. Beneath the silence of the desert, forces generated by gravity, erosion, and ancient geological structures continue shaping the plateau. The result is a fissure that defied earlier expectations about canyon stability and revealed a more dynamic reality. Rather than representing an isolated curiosity, the black crack demonstrates how entire canyon systems respond to the removal of rock by erosion. Its depth, length, and striking appearance capture public attention, but its greater significance lies in what it reveals about the hidden mechanics of landscape evolution. Long after the rivers carved their canyons and long after the sandstone dunes hardened into stone, the plateau remains in motion. The black crack marks one place where that motion became impossible to ignore, a dark opening in the heart of Utah's canyon country, carved not by a sudden catastrophe, but by the persistent and patient forces that continue reshaping the American Southwest.